Okay, so number 13. So we have a boat that's setting out on a bearing of 115. So remember with ships and planes, the bearing was north, south, east, west. And we have basically a reference of the North Star saying this is 0 degrees. This would be 90. This would be 180. This would be 270. And this would be 360. So if I'm setting sail at 115, it's going to be somewhere around here that first leg is going to go out. And it's going to go out for 3 miles. So let's go ahead and draw something that is setting sail on that. Let's say that it's the first leg. So we'll just say that the magnitude of A is 3 miles. Okay. Now from there, we're going to turn and travel for 5 miles on a bearing of 200. So from here, so this is our new place of origin. If I were looking at bearings, which 200 would be about right here, I'm going to have that direction doing something like that. So it's in that third quadrant, if you will. So if I'm going to do that second leg, I'm going to draw something that looks like this. And notice how I have it a little bit bigger because the magnitude of this second leg is a little bit longer, and it's at 5 miles. Okay, so sketch a vector diagram to show this situation. The only thing from here that I would have to sketch out is, in fact, the resultant vector, showing this. And this is not drawn to scale per se, this is just a quick sketch. And this would show that it's going to be A plus B. Okay, so you have the magnitude of A is 3, the magnitude of B is this, and we're going to look for A plus B and also its magnitude and see what we're looking at. So, first of all, A is completed. Now let's look at, tell how each of the navigational bearings would measure in trigonometric angles of rotation. So we're trying to change bearings over to the trigonometric, otherwise rectangular or rotational angles. So this right here is the unit circle, and this right here is the North Star representation. Okay? So how do I change from one to the other? I'm simply going to take 90 and subtract whatever it is they give me in bearings, which in this case would be 115. So in my calculator, if I do 90 minus 115, I'm going to get a negative 25. So this right here, the first leg is the directional angle of negative 25 degrees, which does make sense because it looks like you just went from 0 down 25 and there's your first leg. Okay, so that's the first one, and we're going to do the second one by doing 90 minus, in this case, 200. And I get negative 110. And this does look like it was negative 110, because like we did before, coming from 0 would give me a negative 90 plus a little bit more, which is like 20 or whatever, to give me a negative 110 representation. So those are good to trust. So we'll say that second leg is going to be 90 minus the 200 is equal to the negative 110 degrees. Okay, so your goal was to change it to those angles because we're going to show the work in part C to answer our questions. So here we go. We have the table, and we have 3 vectors. The first one we'll say is the A, then B, let's do B in red, and then let's do A plus B, the resultant vector, in black. So A, the magnitude of A is 3. The directional angle that we came up with was that negative 25 degrees. B, the magnitude was 5, and the directional angle was a negative 110 degrees. And we're simply going to get our component vectors x and y right here by doing the magnitude times the cosine of the angle, and then the magnitude times the sine of the angle. So let's do that real quick. We have 3, and we have negative 25. So 3 times the cosine of negative 25, 3 times the sine of negative 25. Oops, I gotta change that because it's not negative point, it's just negative 25. And I gotta control answer, whoops. And then control answer, so that we get our components are the following. So our components are gonna in fact be the 2.6 So 2.7189 is the x value, and the negative 1.268 is the component for the y value. Okay, so now let's do b. B is going to be 5 times the cosine of negative 110, and then 5 times the sine of negative 110. Let's see what the calculator gives us for those. We have a negative 1.710 and a negative 4.698. So let's go ahead and write that here for our components. So x is negative 1.710 and a negative 4.698 for the y. Now we're going to add these vectors because, again, our resultant is the most important thing, because then we'll work backwards to get those other two pieces. So let's see what we get. So 2.7189, and I see that I put that to 4 decimals. No worries. 719 we'll round it to. And we'll add a negative 1.710 to get a 1.009 component for the x. Okay, so now we're going to add the y values and get negative 1.268 plus negative 4.698 to get a negative 5.966. That is the y component for my resultant vector. Okay, so now, quickly we could do the sum of the squares square rooted. So we'll have the square of 1.009, negative 5.966. Make sure that negative is inside the parentheses. And let's see what we get for our resultant. So the square root of parentheses 1.009 squared plus parentheses negative 5.996. 5.0966. So, and then this one's going to be squared, and let's see what we get. We get a resultant of 6.051. So 6.051 is the resultant. And now we're going to do the arctangent of a positive x, negative y, which means positive x, negative y is in the fourth quadrant. So whatever it is, we're not going to add 180. We're just going to see what we get as far as an answer. Negative y value over the positive x value. Let's see what we get in our calculator. Okay, so we have the arctangent, control divide of negative 5.966. Whoops. And then we're going to put that over the 1.009, and we get what you see here of negative 80.401. So negative 80.401 degrees. And that does in fact look like our resultant if this is where we're originating. So a negative, almost a negative 90. This is traveling at a negative 80.401 degrees. Okay, so use the vector sum to determine the boat's distance from the port at the point described and show your work. So the distance from the port is just this magnitude. So you would say the distance is equal to 6.051, and in this case you have miles. If it did ask for the direction, you could say negative 80, or if it asked for the bearing. So if it asked for the bearing, you would take this and you're going to convert it to bearing by putting 90 minus this value of a negative 80.401 degrees. So you would go to your calculator, you'd say 90 minus, minus this answer, and you get a 170.401. I know it's not asking, but it's extra practice. The bearing angle would be 170.401 degrees, with the rectangular angle being this negative 80. So we'll say the rectangular angle is equal to that. And that's how you would answer this one. Now, there is a program that I think I'm going to let people use that will get you to that answer fairly quickly, simply by knowing how to answer the prompts that it prompts you with. Okay? So the program that I would possibly share with you if you've gotten an A on the first or second quiz is going to look like the following. So only those individuals I transfer the program to, and you would go to this vector and say that there are two vectors, and it would ask you what's your first magnitude, which in this case was 3 miles. Okay, so you would put 3 here. Then it would say what's your first bearing, which in this case was 115. It's doing all this work that we just did in seconds. So 5 miles is the next one. And then last but not least, your bearing for that last one is 200. And it does all that work for you, and you see that the bearings is 170.401, very close to what we got, and the magnitude is 6.051, which is exactly what we got. And finally, the resulting components themselves are what we got down here as far as being the resultant components for that y.